Woohoo, welcome back. Tonight we're going to be working with a second example of a nonlinear inequality. And this is going to be one where there's a really cool trick that you can take advantage of, which I think is really cool. So we'll see if you think it's really cool. And this has to do with a word problem that deals with bonfire temperatures. And the problem says in the vicinity, so close to a bonfire, the temperature T in degrees Celsius, so this is already metric, at a distance of X meters, so doubling down on the metric, so we're really in metric land, from the center of the fire was given by this expression, which I know already looks really scary. So, capital T, the temperature is 600,000, which is really a large number, very high temperature. But down here, we've got x squared plus 300. That's the temperature, x meters from the center of a fire. So if we have this fire, yes, that is my beautiful drawing of a fire with logs underneath, although it's not clear that everyone would think those were logs, but let's just go with it. A little fire here. Some red. Fun fact, you can doodle if your brain needs a little bit of a break. It's a really great thing to take some time. Draw a picture, especially if you're stressing out about a problem. It helps to shift the awareness in your brain and help ground you. So draw a picture. So back to what this is. At a distance of x meters. So I'm going to be X meters away from the fire, the bonfire, and this is the temperature. And the question is, at what range of distances from the fire center was the temperature less than 500 degrees Celsius? So I look there, degrees Celsius, yep, that's correct, so I don't have to convert anything. I just want to make sure that it's less than 500, so I've got a less than 500. And dum dum dum, I have now an inequality. And in fact, it's nonlinear. Why is it nonlinear? Well, a bunch of reasons, actually. X is in the denominator. That's never good. If you want something to be linear, starting with x in the denominator is right out. The other thing is we also have x squared. So we have a quadratic. So it's kind of like extra nonlinear. But there is a very, very cool thing that's happening with this. And it is, hopefully it's something that I can explain to you. And if not, what you can do is you can go ahead and if you watch the previous part 1 video, we would take the 500, move it over to the left, find a common denominator, combine, do all of those steps, follow those steps, and you will absolutely get to the correct answer. And that's awesome. However, there is a cool trick to this one. And I don't know whether you think it's a cool trick, but I'm going to tell you about it and see what you think. So it turns out that x squared is always equal to 0. This is a fact. Now, is it always a fact? No. Complex numbers, so if x is allowed to be imaginary, of course, this is not true. We're in the real world. We're building bonfires. So we're generally not going to be looking for imaginary or complex answers. And so we can be pretty sure that in the set of real numbers, we know x squared is greater than or equal to 0. Because something squared either is going to be positive or if x is 0, it's going to be 0. So x squared plus 300 is strictly greater than 0. And why is that? Well, we know this is at least 0, and then we're going to add 300 to it. So it could be something really big. It could be 1,000,000, or it could be 5, or it could be 0. But regardless, when we add 300 to it, it's definitely going to be greater than 0. So take a moment to think about that. Ask questions, pause the video, ask me, ask the tutors. But if you agree with me, or when you agree with me, once we know this is greater than 0, then we've got a lot more flexibility. In the previous problem, we had x plus 1 and x, I'm forgetting, I think it was x minus 2. I can't remember. Yes, x minus 2. And with those, you don't know when they're positive or negative. You know, sometimes they're positive, sometimes they're negative. With this one, it's always positive. So since it doesn't switch, it doesn't go from positive to negative, that means that this always has a constant sign. It's always positive. So we are allowed to multiply by it. So I'm allowed to multiply on both sides by this and not change the inequality. Notice the inequality did not change. And so now I can cancel. So then I've got 600,000 is less than, and then 500 times x squared plus, and then I have to multiply 300 times 500. And you know I'm not going to do that in my head. So let's give it a try. Well, maybe you don't know that. It's 15 with a bunch of zeros, right? It's 15 with 4 zeros. So that's 150,000. So far, so good. Woohoo. So then we can go ahead and see, okay, I've got numbers over here. I've got numbers over here. And what I've really managed to do is I have gotten this x squared, which is still nonlinear. It is no longer in the denominator. And so from my perspective, this is an easier version. Now, I don't know if you'll agree with me. And to be fair, everything that we did in the previous problem, we could still do for this problem if you wanted to. But what I'm going to do instead is I'm going to say, okay, let me subtract the 600,000 from both sides. And then I'm going to make that 0 over there. And I've got 500x squared. And this is going to be minus 450,000. Or, in other words, let's see if I can factor this out. 500 times the quantity x squared minus, and then 450,000 divided by 500, it's going to be 9 something, 900. Nice. Okay, so if you recall, the process here is you get the 0. Then we're going to factor. This is so we can find all the zeros, right? So let's see, I've got 500, and then x squared minus 900, turns out that that's a difference of two squares. I get x plus 30, x minus 30. And then I've got a couple of zeros here. What are my zeros? Well, this x plus 30 equals 0 when x, can you see this? Yes. X equals negative 30. And x minus 30 equals 0 when x equals positive 30. This is finding the zeros. So let's go to the next page and talk about what the next step is. Okay, so pardon me, Sharktopus. Let's come over here. Okay, so let's see, can I get this all in? Not really easily, so I'll do it kind of like that. So I have a situation where I've got 0 is less than 500 times the quantity x plus 30 times the quantity x minus 30. And I know this gives me negative 30 as a 0, and this gives me positive 30 as a 0. And I'm going to say this is very hard to read. So I'm going to take the whole thing and I'm going to turn it around. I'm going to write the 500 times the x plus 30 times the x minus 30 on the left and the 0 on the right. Now I want to preserve the meaning. So which way should the inequality face? And I see that the little end, the pointy end, is pointing towards the 0. And the big end, the open mouth, is towards the 500. So I want to preserve that. So, okay, what we're looking for is a situation where this whole thing is greater than 0. So let's take a look at when that's going to happen. So I'm going to look at my x plus 30 and my x minus 30. And I know I've got zeros at negative 30 and positive 30. And I'm going to need to pick numbers in between. So if I pick a number like 0, and I could pick a number like 50, and I could pick a number like negative 50. Remember, the numbers in the parentheses are whatever you choose them to be. You just have to pick a number that's sitting in that range right there. So whatever you want. I like 0 if it's in the middle, but you could pick 5. And then we're going to find out what signs each of these have. For example, x plus 30, if x is negative 50, that's negative. At negative 30, that's 0. At 0, 0 plus 30 is 30, positive. At 30, 30 plus 30 is 60, that's positive. 50 plus 30 is 80, that's positive. Okay, let's try the x minus 30. At negative 50 minus 30, negative 80. Negative 30 minus 30, negative 60. Oops. I don't usually write in the number. I just usually write in the... My hand was listening to my mouth and not listening to my brain. That happens sometimes. Especially when there are Fritos around, chili cheese Fritos. Yeah, then my brain listens to my mouth, not the rest of me. It's like, yes, give me the chili cheese Fritos. 0 minus 30, that's negative. 30 minus 30, that's 0. 50 minus 30, that's positive. Okay, let's look at the whole expression. The whole expression is 500 x plus 30, x minus 30. So the 500, by the way, is positive, so we don't have to worry about that separately. It's going to preserve whatever the sign is. So a negative times a negative is a positive. A 0 times a negative is a 0. A positive and a negative is a negative. Positive and a 0 is a 0. Positive and a positive is a positive. Okay, so I am looking for, in this case, numbers which are greater than 0. So I want this and this. So I want to be here, and I want to be here. So my answer is going to be from negative infinity to negative 30. Jump over all this stuff in the middle from 30 to infinity. Or x is less than negative 30, or x is greater than 30. Okay, this as math is fine. Of course, that's beautiful math. The problem is, and here's Sharktopus to remind us, that we were at the beach enjoying a lovely bonfire. So what the heck does this mean with a bonfire? And in fact, Sharktopus is asking that too, because Sharktopus doesn't get to see a lot of bonfires. Although he can run along the surface of the water, nobody thinks to invite him to any bonfires. It's actually very sad. Okay, that's okay. We'll have a bonfire just for you, Sharktopus. Okay, so it says, in the vicinity of a bonfire, the temperature T, blah, 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 at a distance of x meters from the center of the fire. Okay, so what if the fire is right here? What if this is the fire? What does it mean that x has to be less than negative 30 or greater than 30? And the answer is you can see right here. So in other words, what the math is telling you is that you need to be 30 meters in this direction, or you need to be 30 meters in this direction. And in fact, that's probably misleading. I did little tiny, I could have done that better. I could think about that better because it should be an open circle, right? Like that to get us to either side. So in this case, why are we ending up with some negative numbers? What does that even mean? And the answer is, well, in terms of a fire, you could imagine that if this is positive distance from the fire, negative would mean basically walking through the fire and going to the other side. So the math is actually telling us something very smart. It's saying, you know what? You need to be at least 30 meters away, either on this side or on this side. So you need to make sure that you're actually going to stay, if this is the fire, you need to stay out 30 meters away from the fire, which is about 90 feet, not exactly. A meter is about 3 feet, but again, not exactly. So, 90 or 100 feet away from this fire in order for the temperature, this is a big bonfire, for the temperature to be less than 500 degrees Celsius. That is a thing. So, that is why it's giving us a positive and a negative, because it recognizes in the equation that we set up that you could be on either side of the fire. So the question is, at what range of distances from the fire center was the temperature less than 500 degrees? And I would write in my answer at a distance of at least 30 meters, the temperature will be less than 500 degrees Celsius. Woohoo! Okay, as always, if I've said something that didn't make sense, please ask. Please find me. Come to the bonfire. Join me at least 30 meters from the center of the bonfire. And let's talk this over. Talk to the tutors, pause the video, replay the video, take another look at the work. This is just one way to do this problem. You could do it a couple other ways that I can think of. But, make sure you understand it, and then, pat yourself on the back. This is a very complicated word problem, and you made it through. Woohoo! You are awesome. So, that's it. Take a break. This is the end of this section. We're going to go on to another section, but take some time for a nice snack. Maybe even some s'mores, right? Some roasted marshmallows. Maybe you can save a few for Sharktopus, who never gets any roasted marshmallows because it's a little too damp in the ocean. And, give yourself a nice break. Remember that you are amazing and incredible, and I think you're awesome. And go forth, math on, and woohoo.